one of the things that's really interesting to me that I didn't really anticipate, like taking a new job a couple years ago, was how a different infrastructure could actually change how I write code, and the availability of different tools really impacts like the way I ship code and kind of the confidence level I have in it. So one of those tools that really impacted me was Zookeeper, which is it's a highly consistent distributed key value store. There's a couple like them, like etcd or Console or something. So this talk isn't necessarily specific to Zookeeper, but it's what we have and it's what we run, and it's pretty amazing. And so the kind of the little background about what Zookeeper is, or none of this is even going to make sense. So it's a key value store, and I said it's highly consistent, and that means so it's distributed. So you have a couple nodes, depending on what kind of failure rate you want to, or failure characteristics you want to achieve. So 3 or 5 or something is common, and so writes have to be accepted by a majority for them to return. So writes are inherently expensive because you have to have a bunch of machines coordinating that value. But reads are cheap because any node can reply to any request and just give you the value. So it's for the kind of load where you just have, it's high reads, low writes. It's great for that. And so the keys in them are hierarchical. They're shown like they're slash separated, kind of like a Unix file system path. And any key can contain data and also children. So kind of like if you take files and directories in Unix and smash them together, that's kind of what this is. And then kind of there's 2 key features that we use a lot that are kind of unique to this kind of system. One of them is a watcher. So any client can register an interest in a specific key, and when it's updated, it'll get a notification. And then it can, so the once and done kind of notification. So once it sends it, then it deregisters you. So at most get 1 notification for a change. And then another one is ephemeral nodes. So when you can, as a client, register this node and mark it as ephemeral, and then when you disconnect, or if the process dies or whatever, your connection to Zookeeper goes away, then Zookeeper will delete that for you. They're used in conjunction a lot, so you have one process that starts up and creates this ephemeral node and other clients watching that, and when it goes away, it knows that that original process died or is finished or whatever, depending on what the application is doing. So I've got a couple examples. The first one is, so the first common sort of use case or example code you'll see is creating like a distributed lock service. So you have like a resource, like in our case, we have this scheduling service, which is kind of like cron, basically. And so we want 1 of those to be running at any given time. We don't, if you have 2 or more running, that would kind of be bad. And then if 1 fails, we want another one to pick it up. So we have it running on a bunch of different machines at any given time. They all start up, when we ship out code, they all start up, try to acquire a lock. One of them's going to get it, the other remaining are going to be denied, and then all those that are denied register a watcher on the lock, and then when it goes away, then the next one picks it up and keeps going. So this is kind of just a super naive example of what that might look like. So you have, if you're not familiar with Ruby, the $ prefix variables are just globals. That's kind of a, really simple way to throw together an example. So you create a new Zookeeper instance, or a connection to a Zookeeper that's already running. And then the ZK gem is a wrapper around the Zookeeper client library, and it just adds some kind of extra functionality on top of it, like locks and semaphores and a bunch of different primitives that you can use to build on top, so you're not reinventing the wheel all the time. So in this example, super simple. It starts up, tries to acquire a lock with this with lock method, and the semantics of this are: if it gets the lock is executed right away, and if it doesn't get it, it's just going to sit there and wait until it gets it. which is perfect for, it's exactly what the distributed like scheduler we want. It just all start up and just sit there and wait for a lock acquisition, and if you get it, just do some work. And so, I mean, actually running the examples is really not all that interesting because, it does exactly what I said. So, you have this bottom process here, and if you kill it, then another one picks up and takes over. And so the one thing to note about locks in Zookeeper, which it's pretty obvious, like once you think about it a little bit or run into problems with it, but that the locks are advisory locks. Like Zookeeper has no control over what your code actually does. So the resource being locked and the clients trying to acquire the locks, they could do whatever they want. And so kind of in our case, you have this scheduler running, and I guess I should probably start this button so it's running. If it hangs, so I just suspended the process to kind of simulate like what would happen if it would just, whatever, a long garbage collection pause or something, either its connection to Zookeeper was lost. And so Zookeeper obviously, it recognized that it died. I turned down the heartbeat like way down so you wouldn't have to sit here for like a minute waiting for that. And then so another one picked it up. But this first process doesn't actually validate the lock is still valid, so when it comes back on, it's just going to keep going. And so that's where the whole advisory lock part comes in. Like when you're actually doing the work or doing something with the lock, you should check with Zookeeper and actually make sure that this lock is still valid, because it could have gone away. Zookeeper could have went down, or your connection with it could have went down in the time between you acquiring it and doing some work. And so that obviously, in order to validate a lock, requires an extra round trip to the database, which depending on what you're doing may not be reasonable. If you're doing something that's, you're doing thousands of requests per second, like an extra database round trip is pretty bad. So depending on what your application is, you have to keep that in mind. So this simple, this assert just takes the lock that it has, pings Zookeeper, checks to see if it's still valid, and if it's invalid, it'll raise that exception saying that, and then we can, the semantics of Ruby, that retry just goes back up to the top of the begin and tries again. And so this looks a little better. Let's do this one again. Verify locking. And so now we have the same as before. If we suspend this one, we have another one pick up, and then when this bottom one starts up again, it's going to realize it doesn't have the lock anymore because it tries to validate it, and it obviously does not have it, so it doesn't execute anymore.
But wasn't sorry to interrupt, but didn't your recovery thing say that it's supposed to print to the console?
It does. I'm actually not sure why it didn't print it. I tried this 1,000 times, and I swear to you it printed. You know what? Let's try this one again. Yeah, you know what? It's got to be something with this display. It's just not, you just can't see it. It's printing locally. If you could see it on my screen, you would see it.
Oh, yeah.
Sorry, computers.
You need to do the presentation, right?
Right.
For security, we
Can't take your word for it. You don't very trustworthy.
Thanks. And so another, so locks are very common. Like if you're looking up Zookeeper and what people do with it, distributed locks are pretty, like one of the top of the list. Another big feature using the watchers that we use is kind of for configuration, like application level, like bits of algorithms, like you're writing this code and you're processing batches of messages, and you have to set like the batch size, and you're not sure what it should be, so you kind of just guess and put it in there. One thing so in a previous, previously I've done a lot of Heroku stuff, and I was really accustomed to like throwing that in like in an environment variable, and then but changing an environment variable requires, it restarts your application, which, if it takes a minute to start up, that kind of sucks. Especially if, there are web servers, then your entire site is inaccessible for a minute while you restart. And, there's other ways to achieve this without Zookeeper, but that was my previous life. And so coming here, we use this do I have it? Oh, that's right. We have this kind of data structure, I guess you could call it, called a distributed hash table that's backed by a Zookeeper. So you give it a connection and a key, and then it gives you, it's basically just a wrapper around a normal Ruby hash. So it takes that Ruby hash and serializes it and sticks it in Zookeeper. And when it changes, it gets notified and gets the value and updates that hash behind the scenes. So there's just a background thread running to get those updates. And so the great thing about this is you can throw this into like the critical path of your application, because it's just to actually like do reads. Since it's just reading from a hash, you're not doing round trips to the database to get this data. It kind of changed the way I thought about how configuration, like how easily you can configure something. Like you could be like have your system like in the middle of this loop churning through data and be tweaking these values on the fly, and then behind the scenes it's updating its behavior in real time. You're not restarting things. You're not having to like redeploy stuff, and that for me was a great. It really removed a lot of stress, especially when like you have to pick these numbers. You don't know what the heck what, depending on the load. Maybe it works now and it's great, but then when you're under high load or when a database falls over, like then you're doing way too much work and you want to like scale that back. This kind of gives you sort of a quick escape hatch. And so like the first use case for Zookeeper that we had was we wanted to display like a status message at the top of the site. So when you're using the site, if there's some sort of outage or slowdown, so I work at a company called Papertrail, and we do a lot of logs. So you send your logs to us, and we'll store them for you and show them. You can pull up the site and see your logs, search them, all that stuff. So there's tons of failure modes where the website is accessible and you could see logs, but maybe they're delayed coming in. And so, you would be really confused. You're looking here, you're seeing your systems running, but you're not seeing any log output. And so, one of the things, just a little banner at the top saying, hey, there's a message, here's a link that you can, see the status page and get more information or something like that. And so that was just a really simple, like, we just want this hash to have a message and a color and throw that in Zookeeper, and then have all of the web servers in the page render. It checks to see if that is null or nil, and if it is, it just keeps going. It doesn't do anything. And then when, like from the admin console or from the Rails console, you update that in Zookeeper, you set a status message, then the next time a page is loaded, it sees that value, and I didn't have to do any, like, we're not adding an extra database lookup in our page render cycle, because that would be unfortunate. And so I have an example of that, which is the unfortunate part of this kind of presentation is the code is just not that interesting, because this is just kind of me demonstrating how we use it. But I mean, it really is just like conceptually, like thinking about writing code or having a problem where I want to inject or change the behavior of the system and not really having those tools available to me. And so this is, so I was having a little too much fun with these scripts, and I wanted to like mimic the behavior of clients of the request cycle without having to like do Rails. Sorry, Court. So I have this little function that just prints that notice, and then I have this kind of grosser code down here that actually captures the signal, and you don't have to understand this code. That's why I put it at the bottom. So all you need to know is when I hit Control-C, it just prints the notice again. This is doing a lot of work. And so Control C, and it obviously shows you nothing. So if I load up this IRB console, and now I can get a system notice. Ooh. Yeah, so you can see the system notice is new. And so, oops. Yes. And so then there's this update method that if you call it, it sets the hash, and that set actually, goes through to Zookeeper and does the update. So if I update with high and green or something, then Control C like that gets the message. It's amazing when computers work. And then so then that was just kind of a simple example for pulling configuration into your code backed by Zookeeper. Another thing we've done so many times is like rewriting a feature, or either adding a new feature or changing the behavior of an existing feature. If you want to squeeze more performance out of it, or maybe reduce the load. And so we have some ideas of how to achieve that. The stuff that's running on production now is known. At least that's a known quantity. Adding something new is always, at least for me, worrisome, especially when it's like a valuable sort of feature. So feature flags have really changed kind of my life here. I mean, pretty much everything we do that's of substance is backed by a feature flag. And so I'm not even going to really bother running these because they're not flashy demos. But so I mean, really the only thing I changed here was we extracted the original behavior into two methods, and if this configuration was set because I flipped it on, then it hits the new code path, and if it's off, then it's just going to hit the original code path. And all that is just a separate Zookeeper node there that has that config data. And so we have a pretty large, kind of as we've gone, we've like amassed more like configuration stuff and more feature flags, and this kind of gets a little bit out of control. But yeah, we just use the hell out of it, and it's amazing. So.
Do you eventually go back and like once you know it's
Yeah.
stable, do you refactor the flags back out eventually? Or?
Yeah, but that's there's no real process for that. But yeah, like just today I removed one that has been on for months, and I'm like, I probably don't need this anymore. I think it's fine. But yeah, that's on you to figure out.
So the way you're writing your programs are to react to the configurations that you're using in Zookeeper.
Mm-hmm.
Like what? Can you give an example of what kind of things you would be reacting to? Like you said before, like connections, you're getting a lot more traffic to your application. What kind of things would that change downstream?
So a lot of it, a lot of the stuff that's like uncertain, or that's kind of like the environment is constantly shifting, is like dumping logs into the database, and so the writes of logs and the reads, kind of balancing those. If one's too high, you can use all the resources, and so if you have tons of writes, maybe that's going to leave less resources for your reads. And so one of the features that we were fooling around with was changes to like querying behavior. So right now, like kind of the simplistic view is like you query the backend database for like, give me 1,000 logs that match this string. And we were curious what would happen if we like split that up into 5 queries and then join them back. And so that's kind of a scary thing, just to like quintuple, is that what 5 is? Your reads, who knows what that's actually going to do. So that was one of the things we hid behind a feature flag. There's another project called Rollout, which is sort of a Ruby. We made it Zookeeper backed, but it's just a way to like turn on a flag for a specific user or customer, or turn it on for a percentage of customers. And so that was that's kind of one of the things that we've used that for, and because you definitely don't want to just like explode your reads because you have no idea what's going to happen, even if it's behind like a Boolean flag on or off. Like you want to kind of have some fine control over, okay, let's crank up, to 10% of our reads, use this new method and see what happens, and then let it run for a while and see what happens, the highs and lows of the week. If it's causing some problems, then we can quick scale it way back. So it's really all about like sort of mitigating unintended consequences. At least that's kind of mostly how I've thought of it. Is it makes a lot of sense. This may be a terrible idea. I mean, it has the potential to be terrible, but at least if you have some control over it, then it might only be terrible for a little bit, and then you can quick turn it off. But that's also especially this assumes you have a lot of graphs and insight into your production system. Like if you don't have any graphs to look at, like while you're flipping these things on and off, then who knows what your system is doing. So, but that's content for another talk. But yeah, so we'll flip these things on and scale them up in like stair graphs for a day and make sure everything looks okay, and see what happens.
2 questions. The distributed hash table library you guys created, the unique path that you passed to each one, is that like the unique path that identifies it in Zookeeper?
Yeah.
And the second question is, is that like open source? Do you guys open source?
I think that is, I honestly don't know about that. I think it was, I forget now. I'm trying to remember if I saw it in another project that was open source or if it was another one of our internal ones. It's not really all that, I'm sure there are other implementations of this, I guess, as much to say. This was just something that kind of grew from what we were doing. So it could be, probably.
Yeah. It's a cool concept.
Yeah.
It makes things easy.
Mm-hmm. Yeah.
I'm sorry to derail your. So this is not more about the how it changed your coding practices. It's more about the infrastructure of Zookeeper. Is this a completely in-memory key value store?
Yes. Zookeeper wants to be in memory. If you're using too much, that you'll have bad times.
Right. That's what it is. Before you said though that any node could respond to a query.
Yes.
Does that mean that every node has, there's, say you have a 5-ring cluster, you have a copy of all the data in every single node?
Yeah. So it's all, and so there's some like
so
new.
It's not sharded at all?
No, it's all just a clone of it. And so that means, and so it does some really cool stuff with session tracking in that, because you have a couple nodes and you have several writes, you can easily have, while writes are being distributed, you could be disconnected from one and then reconnect to another one, and you're not sure, like there's no guarantee that state is going to be consistent across all of them. So it does some cool stuff with session tracking in that it's basically versioning, like saying, here's as a client, like I got disconnected, I'm reconnecting and reestablishing like an interest in this node, Z node. So all the keys in Zookeeper are called Z nodes. I forgot to mention that. So I'm just gonna start calling them Z nodes now. You can register an interest in that Z node and like pass and attach like a version, like this was the last known state that I know. And so then that your view of the world, it has a lot of like, make sure that you don't see like your perception of the world like go back in time or connect to a client or connect to a Zookeeper node that doesn't have the state that you last saw. So yeah, there's definitely ways that it can get out of whack, but it does mitigate that for you substantially.
So it's eventually consistent?
I don't know if it's eventually consistent to the definition, but sure, let's call it eventually consistent.
Isn't that implied with distributed? Or
You get around that though with some vector clocking.
Okay,
But yeah, so I mean, the simple answer is yes. Like every node has the entire state of the world, and it shares that among all the other ones. So a loss of I mean, that also means that, you know, you can sustain the loss of one and still connect to the other one and know that
Right.
that data is still going to be there. Anything else? That's all I got. All right, thanks.